The warm-up problems. Of course, super easy. You should just be able to write down the answers. This should be easy points. What do you got for A? 5. I wish we could just have a test on this. What do you got for B? X plus 1.
Oh, wait,
And last but not least, C. I hear it, 9x. Because, as I have said, what feels like 5 million times, what's the relationship between logarithms and exponentials? Inverses. They cancel each other out. Okay, we got it. So here's what we have on tap today. How we can work on logs in our calculators in different bases. Remember, the log key on the calculator is defaulted to a base 10. I know you probably know how to type the other bases in, but I'm going to show you that today too. Of course, we're going to use those 3 properties that are on the board over there to expand some expressions, and we are going to take a look at a couple graphs to review here today. Now, this is one of those things I always kind of even question, is this worth showing you? Because most of you have graphing calculators that have this log-based function in it, but just for the record, if you don't have a base of 10, let's say for whatever reason you don't have your graphing calculator with you, you just have a little scientific one. I can still do a log in a different base on my scientific. To do it, you would just hit your log key of whatever the argument is and divide it by the log of the base number. So even if you forget your graphing calculator, you can still punch them in. Not that you would ever forget your graphing calculator. You could also do it ln style. ln of the argument, remember that's an expression after the log, over ln of the base. Now again, like I said, for most of you, you're never going to use that because you always have your graphing calculators with you and it's in your math menu. So if you hit math menu, and it's not on the screen, you have to arrow way down to letter A, or really what I do is I just up arrow so it brings it up from the bottom. I think that's a little quicker. And you can see you got the log base there, hit enter. And then you can just type in whatever the base is, whatever the value is. And I have a distinct feeling you probably remember that from last year. Maybe some of you were trying to use that on your graphs even. I don't know that we're supposed to be doing by hand, but we'll practice those again today. All right, so punch these in for me. Evaluate the logs, round to 3 decimals. So if you don't have your graphing calculator, you could just do log of 7 over log of 3. So I could even do that on my $8 scientific. Probably don't even have to get that carried away. I would just pull up in your graphing calculator, obviously in your math menu, and type this guy in. 3, right arrow over 7, and there's our answer. And let's round to 3. So I'm going to put 1.771. All right, let's test your calculator skills. Punch that in however you need to punch it in. Oh, it comes out kind of nice. And the answer to B is -2. See, I said that one comes out nice. Got it. All right, so easy peasy. Clearly, I don't need any work for those. Make sure you can type those in your calculator. Now, the graph. This one, of course, says you can use your calculator. Okay, so let's type it in. I'm going to go into my y equals menu. Who knows what's in there? Let's clear that out. All right, and I'm going to go back into my math menu. I like to up arrow just because it's a little less keystrokes to press on this thing and get to my log base function, and I'm going to type this in. And of course, x minus 1. And let's hit graph. And I'm going to try not to go on my bender about Texas Instruments, but what do I not like about this picture? Doesn't it look like it stops right there? So we know we're not going to draw that. When we draw ours, we know better. We're going to continue that on, okay? So let's get some points off the table. Let's see if there's anything nice in there. So I'm going to plot like 2, 0. Let's do 3, 1, so on and so forth. 2, 0, 3, 1. What else did we have? Anything good? 5, 2. So, I mean, we have a couple. Now, before I draw this, 1, 2, 3. I can't write and talk here. 5, 2. Let me get it on here. We also probably should get our asymptote drawn. So before I draw this, okay, and plus I want to review on the graphs, because clearly there's graphs on next week's quiz. So we have a log graph. We talked about this yesterday when I did that kind of weirdo voodoo math problem at the beginning of the hour. Remember, you cannot do the log of a negative number. So to do your domain, whatever your expression is, whatever your argument is after the log, you have to make sure it's positive. Now I'm just going to do a little mental math and add the 1 over. And I'm going to be fancy and put all real numbers. And remember, that is a 2 for 1, so to speak. That is also then your vertical asymptote line. And you will need to be able to mark your vertical asymptote on here. Your calculator won't do it for you. Now, of course, I'm going to draw the green curve for the graph, and we know it should continue on. Never trust Texas Instruments. Okay, other thing you would have to identify for me for the graph, of course, this is super easy. What is the x-intercept? X-intercept is? Yeah, and put it as an ordered pair. Okay, we get it. Any questions on how to type it into your graphing calculator to generate the picture? We are going to practice by hand at the end of this, just for the record. Okay, other things we're going to use, of course, are those properties up on the board, those 3 properties of logarithms, which clearly are in your notes. On purpose, I put different variables on the board than what's on here, not to mess with your minds, but it doesn't matter what variable it is. It's all about the operations, addition, multiplication, subtraction, so on and so forth. So product property. So here, of course, product, we're talking about the U for dramatic emphasis. I'm going to put the times in there. U times V. That is equivalent to the log base A of U plus log base A of V. So product expands to addition. So we're going to use those properties today. Now, a little common sense here. You know, math is all about patterns. If product goes to addition, quotient's going to go to what? Subtraction. Okay. So we're going to do quotient. Of course, you're going to write it with the fraction bar. We know fraction bar means quotient. So it's going to be the log base A of the numerator minus the log base A of your denominator. And again, I just, on purpose, pick different letters on the board than the U and the V because it doesn't matter. You just have to know product. Quotient goes to subtraction. I'm going to put subtraction in. Now, you're like, why are these properties even important? Like, why are we even doing anything with these properties? These come into play, especially in the next section when we start solving equations. We're going to have to try to condense or simplify some of these in order to help us solve some equations. So we're kind of working our way up to that. Now we also have what we call the power property. So you have this exponent here. That's what we're talking about, the power property. Notice on the board I used P for power. I know that's pretty fancy of me. So all that does is it comes down to the front, the power, and you multiply it to the log. And of course, you don't need the dramatic dot in there. I just put it in, you know, so you know that we were clearly multiplying it together. So power property expands to multiplication. I'm just going to abbreviate multiplication by the power, or the exponent, whatever you want to say there. So we're going to practice using some of these properties, is what we're going to work on next. Now, I'm going to be honest with you. I have a love-hate with these problems, a love-hate, okay? Because couldn't I realistically just pop them in my calculator and be done in like 2 seconds? Okay, yes, of course we could, but they want us to use our properties of logarithms to simplify. So just to kind of practice using the properties is what it is. What we're really after, what we care about, is the last page. When you have the variables in here, I can't type that into my calculator, so I have to know how to do these by hand. So we're just working our way to those, but we're going to start with some numbers. So first things first, I see that 243, and I'm like, oh, it's kind of a big number first off, which I don't love that. But I want to try to, of course, rewrite that using 9, the base number. Because, of course, at the base and the exponent, we can cancel them, all of that sort of good stuff. So I'm thinking about how can I rewrite 243 having 9 in it. So the first thing I would probably do on your calculator, divide it. What's 243 divided by 9? Bunch of it. What do you have? 27. 27, okay. So that's what I'm thinking about, because it's all about 9. I'm trying to use the base. Now I'm like, oh, 27. Does 9 relate to 27? Sure does. So I'm thinking, okay, that's 9 times 3. So this seems like a whole lot of work for something I could have typed in my calculator in a second, but we're going to do it. So I'm going to rewrite this as log base 9 of 9 squared. I'm just going to clean that up, times 3. So now I'm going to use this first property, product property. It expands, of course, to addition. So log base 9 of 9 squared, which that's easy. You should know that. That's going to be easy. Plus log base 9 of 3. Now the first expression's super, super easy. What's the first answer going to give you? 2. Now I'm like, oh God, we're still going, seriously? Because I need to rewrite this 3 using 9. Okay. 3 does relate, of course, to 9. It is the equivalent to the square root of 9. We know the square root of 9 is 3, right? Now, again, oh God, I'm still going. This shouldn't be so difficult. I'm going to leave the 2. I'm going to rewrite the square root of 9. We've seen this pop up in a handful of problems. You're going to see it more today. Instead of the square root of 9, it's 9 to what power? So we did all of this work for a final answer of what? Oh my gosh, 2.5. This is ridiculous. So this is why I say I have a love-hate with these problems. We got to practice multiple properties in one problem, meaning canceling the log and the exponential, converting it into addition. Man, that is very time-consuming for something I could have typed in my calculator in 2 seconds. I got 2.5 and been done with that. But again, we're doing this to kind of practice these properties when we have variables and you can't use your calculator. Now, they tried to help you a little bit on B because they already have the product. They already kind of figured out the numbers for you. So I'm going to go right to my expansion. Product goes to addition. So this is going to be log base 3 of 9 squared plus. So that's no big deal. It's no big deal. Now, here's the spicy part on this one. Your base values are 3. I want to try to rewrite them in terms of 3. So right away, I'm thinking about this guy. Well, 9 squared is really what number? 81, which does relate to 3. 81 is the same as 3 to what power? 4. It's like, why do they have to make this so difficult? So that's really 81. 3 to the 4th is also 81. I rewrote it that style because I want 3. I'll make that a 4 in a minute. Now this. Oh boy. What is 2 to the 4th? 16. Can you rewrite 16 as 3 to some power? Okay. So I'm just going to leave this for right now. Because I can't use my calculator. Allegedly, right? So this is easy peasy. I can't make 16 3 to some power. It's just totally impossible for me to do that without any sort of a calculator. So the only other play I have in motion right now is this third property, because you have the power property. I'm just going to bring the power to the front and write it down. And I can't use my calculator. That's as good as it's going to get. Again, love-hate with these. More of a hate, okay? But it does, we're practicing the properties when we get to the variables, and we couldn't use the calculator. So let's just be honest. You can probably guess by my tone of voice. Are these on your quiz next week? Yeah. These? Okay, let's do this last one. Just to practice our properties. Quotient. What does quotient expand to for an operation? Subtraction. So ln e to the 5th minus ln 7. All right, I like that. That was easy. First expression, easy. What happens to the ln and e? Okay. Now, you can't use your calculator. So can you do anything with ln of 7 if you can't use your calculator? Okay. Or at least seems worth it, because couldn't have I just typed in that original problem in like 2 seconds and just gave a decimal answer and been done? Okay. All right. Use the properties. Good work. To verify the equation. Oh boy. Okay. So they want you to show the one side really does equal the other side. So the first thing I'm going to talk about is what side to start with. 24, I could try to expand it out into this. I think that might be a little hard to make happen. I think it might be easier to take the right side and simplify it down to the 24. So I'm going to work on the right side. And of course, I'm going to work in parentheses first. So a couple things that jump out to me on this right side. You have a number in front. Remember, that's the power property. That's really the exponent on the 2. And I know you know 2 cubed is 8. You can make it 8 if you want. I don't care. The next thing I notice, and I think I'm almost there to be honest with you, addition. Addition condenses down to product. And I was like, oh yeah, I think I got it. Because what's 2 cubed? Times 3. Got it. So again, just practicing the properties with some numbers, which again, I almost think is a little more tricky than this last page when you just have the variables. It's this last page that we're going to work on a lot and that you will see pop up in some equations that I really care about is the last page. Use properties to expand as a sum, difference, constant multiple of a logarithm. So what does that constant multiple of a logarithm mean? Like this, where you have 3 times the log. You don't have a power, okay? Obviously, I can't use my calculator on these because of the x. I just have to use the properties. So easy peasy. You've got product. I'm going to expand that to addition. So it's going to be log base 10 of 5 plus the log base 10 of x. Now also don't forget, if you're feeling tired, could have you just put this? Because remember, if you do not have a specific base number, you're defaulted to a base 10. You're implied to be in 10. So I don't care which way you put it. I'm going to circle them. Just recognize if you don't have the 10, you know it's in 10. Okay, so this one, quotient, expands to what operation? Subtraction. And I'm tired. I'm just going to put log. Log of 5 minus log of x. If you want to put the 10s on, I guess put the 10s on. Got it. I like these. I think these are easier than all those crazy number ones. Okay. Can't have an exponent, because remember, directions. You can have addition, subtraction, or multiplication. So this is the power property. I'm just going to bring that down to the front. I don't care if you put the dot for the times. It's implied to be there. I'm just putting it on there because we're multiplying. Got it. All right. Now, first things first, of course, you cannot have a cube root clearly in the direction. Sum, difference, product. So the first thing I'm going to do is just rewrite this as z to what power? Third. Again, those little roots keep popping up. Now I'm going to use my power property, where the exponent or the power drops to the front. I don't care again if you put the dot, but I'm going to put it on for drama. Multiplication. Got it. All right, any questions on that? Too easy. See, this is the page that is the majority of your homework and what I really care about. All right, let's do this one. Ooh, fancy. Now, we've got 3 variables, x, y, and z. So you're going to have 3 ln's in your expression, first off. Getting fancy here. So same thing. I'm zeroed in that you have quotient. So I'm going to put that quotient out to subtraction. So I'm going to have the ln of the numerator. I'm just putting the dot in because we're going to talk about that being product minus ln of the denominator. Now, if however many variables you have is how many logs you should have in your answer. Well, I only got 2 right now. I need a third one. So now I'm going to work on this product. Product expands to addition. So I'm going to write this as the ln of x plus the ln of y minus the ln of z. Now we're really getting wild. Maybe not. All right, same thing. I don't love the cube root. I would probably rewrite that as the 1/3 power. So we're going to raise this whole thing to the third. So now I'm just going to work on my properties. You can't have a 1/3 exponent in your answer. So of course the 1/3 we're going to drop in the front. I'm going to put the dramatic dot for multiplication as always. Now we have 2 variables in here, x and y. So you should have 2 logs in your final answer. So I'm still going because I only have 1. Okay. So I'm going to work on the quotient part. So the quotient, of course, I'm now going to expand out to subtraction. So the ln of the numerator minus the ln denominator. Now I'm going to do one more thing, and you have choices how you write this answer. Remember that 1/3 applies to everything I wrote in red. So I'm just going to put parentheses around it. You could distribute the third through if you wanted and put 1/3 ln x minus 1/3 ln y. I don't care. All the same thing. But just make sure you recognize that 1/3 is applied to the entire expression. Any questions on that guy? All right, home stretch, everybody. Whew, okay. How many ln's are we going to have in our answer? 3. There's 3 variables. I'd rather have 3 ln's. Now, as always, I'm going to start with this crazy fraction bar, the quotient. I'm going to separate that out to subtraction. So the ln of the square root of x, y to the 4th, minus ln of z to the 4th. Now, again, only 2 ln's, we need 3. So I recognize we have product. So now I'm going to expand the product out to addition. So plus the ln y to the 4th. And I'm just going to leave my minus ln of z to the 4th. So I have my 3 ln's, so that's a win. But remember directions. You can only have addition, subtraction, or multiplication. I can't have all these powers in here, or a square root. Okay? So again, we're going to deal with that. Remember, square root of x is x to the half. We should recognize that by now. So I'm going to drop that half in the front of my ln. I'm going to drop the 4 in the front of this ln using the power property. And I'm going to do the same thing on the back. I'm going to drop the 4 in front of that. 4 ln of z. So obviously these last couple ones are the trickier ones of the day, but I still don't think they're that awful. All right, let's look at this last guy. So again, quotient expands to subtraction. So ln of the numerator, ln of the denominator. Now ln of x, I mean, that's about as simple as it gets, right? Let's just leave it. I don't love this square root. So again, gosh, this keeps coming up. I'm thinking about the square root as a 1/2 power. So now I'm going to use this third, it's in pink over here, this third power property where I just drop this half to the front, and let's take a look at what we got left. Minus half ln, and I still have my x squared plus 1. Now I'm looking at that x squared plus 1, and I'd like to simplify it if I could. I wish it was subtraction, because then I could factor it and, do some product stuff. But it's not, okay? I can wish for it, but it's still not what it is. I can't do another power property because that's just on the x, not the whole thing. I really can't do anything else. X squared plus 1 is just x squared plus 1. That's just our argument, our expression after the log. So that is as wild as it gets. The majority of the homework is this last page of the notes. Any questions I can answer for you off of that? Okay, last page is easy. Now, before I give you the homework, we'll have a no graphing calculator quiz coming up sooner rather than later. So we have to be able to do these without our calculators. So recognize I gave you an exponential for the first one, logarithmic for the second. Exponential is always easier, of course. So I'm going to start with the t-chart. Let's just get some points going. I'm going to put some easy numbers in for x. So what's 1/2 to the 0 power? 1. And I think I pretty much just answered your y-intercept. Let's just go for that right now. All right, let's put 1 in maybe. What's 1/2 to the first? Half. Oh, here come the fractions, right? We could put 2 in. I don't know if I love it. What's 1/2 squared? 1/4. 1/2 cubed. And 8. We're going to keep getting worse and worse fractions, which, my graphing skills, it's hard. I'm going to forget it. Let's do -1. So here we go. Without a calculator, what is 1/2 to the negative first power? Really, what nice number? 2. Because if we flip the fraction, we can change the sign. Okay, I like that. I like that. So that's enough for me to draw it. I know I'm going to get close to this x-axis, smaller and smaller fractions, but we'll never actually hit 0. So I think I really just answered your horizontal asymptote for you. What's the horizontal asymptote? 0. Y equals 0. Is the graph increasing or decreasing? Look at it left to right. It's decreasing, it's getting smaller. Okay, I should have put on here too, let's just add it, domain. What's your domain? All real numbers, because can't you put anything in for a power? Square root, decimal, fraction, negative, I don't care, we'll get an answer. Plus, of course, your graph's going to go all the way to the right. This is going to, of course, eventually curve off all the way to the left. Got it. Exponentials, pretty simple, pretty straightforward. Now, when you go to log, you have to scramble everything in your mind, okay? That's where it gets spicy. So first, I can't do a log base 2 of x in my head without a calculator. I can't. So we're going to put it into exponential. Before we convert it, though, you have to isolate the variable. Sounds very algebra 1-ish. So I want to get this log base 2 of x alone. I'm going to just minus the 3 over. Now remember, to convert to exponential, we start at the base, raise to the opposite side. I'm just going to fill it in the blank here. Equals our argument, x. And you have x alone, so we're ready to go. Usually I like to write it x equals, but it doesn't matter. Now when I do the table, you are putting the numbers in which column? Why? Because remember, everything is backwards in your minds right now. We've got to switch it. So I'm going to pick nice, easy numbers. Let's try, I don't know, how about 3? Why did I pick 3? To get 0. 2 to the 0. And I like to plot as I go. That's just how I go. Okay, I'm going to try 4. Why 4? That comes out nice. What's 4 minus 3? 2 to the first. Got it. Okay, let's try maybe 2. What's 2 minus 3? -1. And what lovely fraction really is 2 to the negative first? 1/2. Now that's probably enough to start seeing the curve, but because I got to answer this guy, the x-intercept. Remember, when you're on the x-axis, y is 0. I'm going to add that point on just because I need it for this. So 0 minus 3, what fraction really is 2 to the negative third? 1 over 8. 2 cubed is 8, so 1 over 8. Lord help me. Trying to graph that. Okay. So let's draw it. We're going to get close to the x, or the y-axis. We won't cross or touch it. So let's fill in x-intercept. We can steal that right off the table there. I'm kind of, I guess, going backwards. What's your vertical asymptote? X equals 0. Because we level off right here. Okay, domain, left to right. So we're above 0, so I'm going to say all real numbers. X is greater than 0. Or, of course, some of you like that interval notation, which is fine too, if you like that. So any questions on that? Okay, so hang on to this, of course. Now,